Okay, I'm back, and you'll notice that up here at the top that I have put the equation that we learned in the previous segment for potential energy. Gravitational potential energy is given by that formula. And we said that potential energy depended on position. So it depended on where you're located at. Now we're going to talk about kinetic energy. And so this time it's going to be E for energy, but we're going to put a K for kinetic. And so it is going to be equal to 1/2 mv squared. And so notice that it depends on the mass of the object, just like this one did. So they both depend on the mass of the object, but this time this formula depends on velocity. It depends on the speed of the object. And also notice it's not just mv, because if it was mv, so if it wasn't squared, do you remember that mv would have been what other concept that we studied in the previous lesson? That would have been momentum, P. Okay, but this is going to be kinetic energy, and it's 1/2 mv squared. Now you might be wondering, well, where does that come from? Well, it comes from calculus. So if you take a calculus class, you would learn how to derive this equation. But just trust me that it's a 1/2, and then you have to square it. That also should look familiar, because do you remember when we talked about the how far equation? And the how far equation was the one that said that the distance r is equal to your initial speed times time plus 1/2, and then it was a and then t squared. So do you notice that this has the same look to it as this thing up here? And it's because of the calculus. And so let's not worry about that. So the main thing is, this is the formula for kinetic energy. So notice that it depends on two things. So it's going to depend on the mass of the object and how fast is it going. All right, now let's try it. Let's say that you have a car and it's sitting still. How much kinetic energy does it have? Okay, so answer is 0. So if it's not moving, it has 0 velocity. 0 squared would be 0, and 0 times anything would be 0. So it has no kinetic energy if it's not moving. Now you're saying to yourself, though, but it's so big. The car is so big, it's got to have a lot of kinetic energy. It is true, it has a lot of mass. But anything multiplied by 0 is going to be 0. So it doesn't have any kinetic energy. So the faster an object is moving, the more kinetic energy it's going to have. Even a little thing can have a lot of kinetic energy. So think about a bullet. So if a bullet is in your hand, it doesn't have any kinetic energy because it's not moving. But if that teeny tiny little bullet is moving at 100 meters per second, well, that's a lot of speed. So it's possible that if the speed is big enough, it can overcome the fact that m is small, and then again you have a lot of kinetic energy. So take a look at that picture there. So that's a picture of what? It's a picture of a boxer hitting another boxer. Now that boxer, when he throws a punch, it has a lot of kinetic energy. Why? What's his fist doing? The fist is moving. So it has a lot of speed, so therefore it's going to have a lot of kinetic energy when it makes contact. But do you notice in the picture, can you see the posture of the guy who's throwing the punch? Do you notice anything odd about his posture? Do you notice that he's leaning into the punch? So why doesn't a boxer just, do that? So the faster he can punch, the more energy he's going to have. But why do you think that a boxer leans into the punch? It's to put more mass behind the punch. And then that increases the kinetic energy of the punch. Okay, questions? I hope not. So now we have discussed what kinetic energy is. It's energy of motion. Something has to be moving in order to cause kinetic energy. So here is a sample question. Car A is traveling at a certain speed. Car B has the same mass, but is traveling 5 times the speed of car A. Which car has more energy and how much more? Now, I bet you that if I had asked you that question before I had showed you the equation, you would have said 5 times the speed, 5 times the energy. No, that's not true. Because what do you have to do to the speed? You've got to square it. So it's not going to be 5 times the energy. It's going to be 5 times 5, or 25 times the energy. This class can save your life. You don't believe me, but it's true. Because when you're out on the highway, you know that if you're following a semi-truck, you have to leave room between you and the semi-truck. Why? So if the semi-truck slams on their brakes, you've got time to slam on your brakes and avoid hitting them. So you need to have a space between you and the semi-truck. Okay, now let's say that you're going 2 times faster. So you're going twice the speed, he's going twice the speed, okay? And the question is, how much room should you leave between yourself and the semi-truck? Okay, I'm betting that at least some of you are saying, well, if I'm going twice the speed, I need to have twice the stopping distance. What did you forget to do? Remember, how much more energy are you going to have? If you have twice the speed, it's going to be 2 times 2, which is going to be 4. And that's the energy that you have to overcome in order to be able to stop. And so therefore, you're going to need 4 times the stopping distance. All right, so what's the moral? The next time that you're out on the highway, remember to bring your calculator, okay? So that you can calculate exactly how much stopping distance that you're going to need to have. No, don't do that. All right, so again, don't sue me. So just remember that the faster you go, the more stopping distance you're going to have between that person that's in front of you. Now this one here, here's your math one. So you've got a bullet, and I give you the mass of the bullet. It has a certain amount of energy when it's fired out of a rifle. What was the speed that the bullet was traveling at? So I gave you the M, I gave you the E, and you need to find the V. So what's an equation that has an M, an E, and a V in it? Well, it's kinetic energy. So we plug in our numbers there, and we get the speed of the bullet, and then don't forget to put the unit on the end of it. So it's a speed, it's a velocity, so it's a meter per second. So that's how fast that bullet would be coming out of the gun. Okay? Now, notice that we have talked about potential energy, and we've talked about kinetic energy, and now we could put the two together. So the total energy of an object is going to be the sum of its potential energy plus its kinetic energy. And so we will discuss that in a future segment. And so we're going to take a break, and then when we come back, we're going to talk about the concept of work.